Hello everyone, welcome back to our channel Problematical. Today we'll discuss miscellaneous exercise from chapter 3 Trigonometric Functions, class 11th Maths NCERT. So first thing is you have to prove LHS is given to you and RHS is 0. We have something plus something like cos A into cos B plus cos C plus cos D. So multiplication of two cost values, and there are three terms. LHS is equals to 2 cos pi by 13 into cos 9 pi by 13. Now here cos 3 pi by 13 plus cos 5 pi by 13. So let's apply cos A plus cos B in the second and third term first. This is equals to 2 cos pi by 13 multiplied by cos 9 pi by 13 plus cos A plus cos B is 2 into cos A plus B by 2, 3 pi by 13 plus 5 pi by 13 whole upon 2 into cos 3 pi by 13 minus 5 pi by 13 divided by 2. 3 pi by 13 is 3 pi by 13 plus 5 pi by 13. 3 plus 5, 8 pi by 13 whole divided by 2 is 4 pi by 13. And 3 pi by 13 minus 5 pi by 13 would be minus 2 pi by 13, which is divided by 2 minus pi by 13. Cos minus theta is equals to cos theta. So first two terms, cos pi by 13 into cos 9 pi by 13 plus 2 times cos 4 pi by 13 into cos pi by 13. We take 2 cos pi by 13 common. We're left with cos 9 pi by 13 plus cos 4 pi by 13. Again, in the bracket, we can apply cos A plus cos B formula. This is equals to 2 cos pi by 13 into cos 9 pi by 13 plus 4 pi by 13 whole upon 2 plus cos 9 pi by 13 minus 4 pi by 13 whole upon 2. This is equals to 2 cos pi by 13 into 9 plus 4 is 13. 13 pi by 13 is pi by 2. So this is cos pi by 2 plus 9 pi by 13 minus 4 pi by 13 would be 5 pi by 13 upon 2 is cos 5 pi by 13 into 2 is 26. Now this is in multiplication. Cos A plus in multiplication because addition was converted into multiplication. We know that cos pi by 2 is 0. So this makes the whole thing is 0. Pi by 13 into 0 into cos 5 pi by 26. Multiplication of 3. So this is equals to 0, which is your RHS. Next, sine 3x plus sine x into sine x. So LHS again is given to you and your RHS is equals to 0. LHS is equals to Sine 3x plus sin x into sin x plus cos 3x minus cos x into cos x. And open the bracket, which is sin 3x into sin x plus sin square x plus cos 3x into cos x minus cos square x. Now, sin square x minus cos square x is minus cos 2x. Here sin A into sin B, or better yet, you can merge these two. This value, this term and this term, write them together. Sin 3x into sin x plus cos 3x into cos x. Here you have minus sin common, cos square x minus sin square x. I've taken minus sin common. Now your first two terms, like they look something like sin A into sin B plus cos A into cos B. Sin, cos, tan. It looks something like this. So you can write this as cos A minus B, dx minus x, and minus cos 2x. This is equals to cos 2x minus cos 2x will be equal to 0. And we know that this value will be equals to cos of A minus B. Like this is what it looks like, and this is cos A minus B by formula. Next, cos x plus cos y whole square plus sin x plus sin y, sin x minus sin y whole square. LHS is equals to, let's expand it, we'll get cos square x plus 2 cos x cos y plus sin square x plus cos square y plus sin square y minus 2 sin x sin y. This is cos square x plus sin square x, so you'll get 1 cos square x plus sin square x. Cos square y plus sin square y again is 1 plus 2 times common cos x into cos y minus sin x into sin y. Now this can be written as 2 plus 2 times cos of x plus y, which is the formula. We take 2 common, we're left with 1 plus cos plus y. Now we know that 1 plus cos 2 theta is equals to 2 cos square theta. Here you have 1 plus cos x plus y, which means your 2 theta is equals to x plus y, which means your theta will be equal to x plus y divided by 2. So on the right hand side, in place of theta, we can place this 2 cos square x plus y divided by 2. This you place it here. 2 into 1 plus cos 2 into 2 cos square x plus y divided by 2, which is equals to 4 cos square x plus y divided by 2, which is your RHS. Next, again you have your LHS, and we'll solve it because it's like relatively more number of terms, it has more number of terms, and you'll come up with RHS. Let's expand again. So your LHS will be equals to cos square x plus cos square y minus 2 cos x Again, this will be equal to plus sine square x plus sine square y minus 2 sine x sine y. But this value is supposed to be equal to this. You're supposed to, this is your LHS, and you're supposed to prove this equal to 4 sine square the angle. Cos square x plus sine square x is 1. Cos square y plus sine square y will be equal to 1. You have 1 plus 1 minus 2 common. You have cos x into cos y plus sin x into sin y. Again, this is 2 minus 2. Cos x plus cos y, it is cos x plus x minus y. You take 2 common, you're left with 1 minus cos x minus y. Again, 1 minus cos 2 theta is equals to 2 sine square theta. So applying this over here, you have 2 into 2 sine square. This is 2 theta, so theta would be x minus y upon 2, which is equal to 4 times sine square x minus y upon 2, your RHS. Next, in LHS you have 4 terms, and in RHS you have 1 term with as the product of 3 trigonometric functions. Now let's group. You can ideally group either of the 2 terms. So your LHS is equals to sin x plus sin 5x. We are grouping this plus sin 3x sin 7x. Sin A plus sin B is 2 times sin A plus B divided by 2 into cos A minus B divided by 2 plus 2 times sin A plus B divided by 2 into cos A minus B divided by 2. Here you can take 2 common for starters. You will left with 5 plus 1, 6. So you have sin 3x into cos minus 4 2x, because minus 2x will be equal, cos minus 2x will be equals to cos 2x plus 7 plus 3 10 divided by 2 5 sin 5x into cos minus 4x divided by 2 minus 2x, which is 2x. Here you can again take cos 2x common. You're left with sin 2x, sin 3x plus sin 5x. Again, you can apply the formula. Cos 2x into 2, or you have sin 3x plus 5x divided by 2 into cos 3x minus 5x divided by 2 is equals to 2 into 2, which is 4 cos 2x into sin 8 means 4x into cos minus x, which is cos x. Let me recheck the question. Yeah, I copied the question. Should have signed over here. Okay. We have 4 cos 2x, 4 cos 2x into sine 4x into sine 4x into cos x. So this is your RHS. Next, LHS. Again, you can apply the formula. Sine A plus sine B is equals to 2 sine A plus B by 2, 7x plus 5x divided by 2 into cos 7x minus 5x divided by 2, A minus B by 2 plus 2 times sine 9x plus 3x divided by 2 into cos 9x minus 3x divided by 2 whole upon cos A and plus cos B is 2 times cos 7x plus 5x divided by 2 into cos 7x minus 5x divided by 2. Second term as well, you have 2 times cos 9x plus 3x divided by 2 into cos 9x minus 3x divided by 2 is equals to 2 times sine 12x divided by 2 is 6x into cos 7 minus 5 2x divided by 2 is x plus 2 sine 12 by 6x into cos 9 minus 3 6 which is 3x whole upon 2 times cos 7x plus 5x 12x by 2 is 6x into cos 7x minus 5x 2x by 2 is cos x plus 2 times cos 12x by 6x into cos 9x minus 3x is 3x. Here you can, in the numerator, you can take 2 times sine 6x common. You're left with cos x plus cos 3x. In the denominator, you can take 2 times cos 6x common. You're left with cos x plus cos 3x. The whole bracket gets cancelled and 2 gets cancelled. This is tan 6x, which is your RHS. Next, 3 terms in sine with different angles are given in the LHS, and you have RHS as a single term with 3 trigonometric functions, different angles again. Okay. LHS is equals to sine 3x plus sine 2x minus sine x. Merge these two. Sine 3x plus sine A minus sine B is 2 times cos A plus B 2x plus x by 2 into sine 2x minus x divided by 2. Here you will get sine 3x plus 2 times cos 3x by 2 into sine x by 2. Now you have sine 3x and you do not have anything common in that. But here you can apply double formula. This can be written as sine of 2 into 3x by 2. 3x by 2 is your 2 times 3x by 2, 2 theta. That's 2 sine 3x by 2 into sine x by 2. this is equals to 2 sine 3x by 2 into cos 3x by 2 plus 2 times sine 3x by 2 into sine x by 2 is equals to 2 times sine 3x by 2 common. So left with cos 3x by 2 plus sine x by 2. Just hold on. I think I made a mistake. Yeah. Cos. Right. So take cos common. 2 times cos 3x by 2, and in the bracket you have sine 3x by 2 plus sine x by 2. This will be equal to 2 times cos 3x by 2. Here you are applying the formula of sine A plus sine B, which is equivalent to multiplication multiplied by 2 times sine 3x by 2 plus x by 2 upon 2 into cos 3x by 2 minus x by 2 whole upon 2. This is equals to 2 into 2 is 4 cos 3x by 2 into sine 3x by 2 plus x by 2 is 4x by 2, which is 2x. 2x divided by 2 is x sine x into cos 3x by 2 minus x by 2 is 2x by 2, which is x whole upon 2 is x by 2. This is your RHS. Next. Now for the remaining questions, you have to find sin x by 2, cos x by 2, and tan x by 2 for each of the following 8, 9, 10th question. Tan x is given as minus 4 upon 3. Tan x is given and x is in second quadrant. Sorry, if x is in second quadrant, then x lies between pi by 2 and pi. Means you have to find for for x by 2 angle, half angles. So this is dividing by 2, pi by 4 less than x by 2 less than pi by 2. Here your x lies in second quadrant and x by 2 lies in first quadrant. This is what we have interpreted. In the second quadrant, your x will be second quadrant, your sin x and cosec x are positive, and here all trigonometric functions are positive. Okay. With this knowledge, your tan x is equals to minus 4 upon 3. So you can get the value of sec x is equals to root of 1 plus tan square x, which is equals to root of 1 plus minus 4 upon 3 whole square, which is equals to root of 9 plus 16, 25 upon 9. Now this is in second quadrant, sec is negative, so it should be minus 5 upon 3, which means your cos x will be equals to 1 upon sec x, which is minus 3 upon 5. So cos and sec both are negative in the second quadrants. Once you have cos x, you can get half angles easily. 1 plus cos x is equals to upon 2 is equals to cos square x by 2, means cos x by 2 is equals to root of 1 plus cos x upon 2. This is equals to root of 1 plus cos x is minus 3 upon 5 whole upon 2 of 5 minus 3, 2 upon 5, 1 upon 5. So your cos x will be equals to plus minus 1 upon root 5. All trigonometric functions are positive in the first quadrant, so it is positive 1 upon root 5. If you do not want the root 5 in the denominator, you can write cos by x by 2 is equals to plus 1 upon root 5 rationalize into root 5 upon root 5 is equals to root 5 upon 5. Next, cos x by 2. We know that 2 times sine square x is equals to 1 minus cos 2x, or you can write sine x by 2 is equals to 1 minus cos x, or you can write this implies your sine x will be equal to root of 1 minus cos sine x by 2 is equals to root of 1 minus cos x upon 2. All you have to do is substitute the value of cos x. Cos x is minus 3 upon 5. This is root of 1 minus 3 upon 5. So it is addition upon 2. This will be equal to 5 minus 5 plus 3, 8, 4, 4 upon 5, root 4 upon 5. This is equals to 2 upon root 5, because all trigonometric functions are positive in the first quadrant. So your sine x by 2 will be equal to 2 upon root 5 into root 5 upon root 5 is equals to 2 root 5 upon 5. Tan x by 2 is equals to sine x by 2 upon cos x by 2. This is equals to 2. Let's place this 2 upon root 5, where root 5 is in the denominator and cos is 1 upon root 5 is equals to the values of required values are, this is cos x by 2, cos x by 2, sin x by 2, and tan x by 2. Next, your next question is cos x is equals to, next question is cos x is equals to minus 1 upon 3, where x lies in the third quadrant. cos x is equals to minus 1.3. X lies in the third quadrant means x lies between pi and 3 pi by 2. Which means your x by 2 will lie between pi by 2 and 3 pi by 4. This is third quadrant. This is second quadrant. Now in third quadrant we know that tan and cot are positive. And in the second quadrant we know that sine and cosec will be positive. Tan x and cot x are positive and sine x by 2 and cosec x by 2 are positive. Cos minus 1 by 3, cos x is already given to you. So here you can directly apply the formula. Your sine x by 2 will be equals to root of 1 minus cos x upon 2. Similarly, your cos x by 2, you can even memorize these as formulas. 1 plus cos x upon 2. So your sin x by 2 will be equal to root of 1 minus 1 by 3 upon 2, which is 1 plus 1 by 3, which is 3 plus 1, 4 by 3, which is 2 by 3. So this is equals to root of 2 by 3. Next, cos x by 2 is equals to root of 1 plus minus 1 by 3 upon 2. This is 1 minus 1 by 3, which is 2 by 3, and divided by 2 is 1 by 3. Root of 1 by 3. Now we are in x by 2, we are in the second quadrant. Sine is positive, cos is negative. So we have sine x by 2 equals to root 2 positive upon root 3. We can rationalize this and we'll get root 6. Rationalize this by multiplying by root 3 and dividing by root 3, we will get root 6 upon 3. Cos x by 2 is equals to negative, which is minus 1 upon root 3. Next, tan x by 2 is equals to sin x by 2 upon cos x by 2. Your sin x by 2 is root 2 upon root 3, and here you have minus 1 upon root 3. Root 2 upon root 3 upon minus 1 upon root 3. The denominators get cancelled, you are left with minus root. Next, your 10th question is written that sin x is given 1 upon 4 and x lies in quadrant second. With sin x, we can calculate cos x. Cos x is equals to root of 1 minus sin square x, which is equals to root of 1 minus 1 by 4 whole square, is equals to root of 4 square 16, 16 minus 1, 15, 6, 15, which is equals to plus minus, but x lies in the second quadrant, cos is negative, so it is minus root 15 upon 4 cos x. Now, x lies in the second quadrant pi by 2 to pi. Dividing it by 2, you get pi by 4 less than x less than pi by 2, which means this is first quadrant. In second quadrant, sine and cosec are negative, are positive, and in the first quadrant, everything is positive. So now your sine x by 2 is equals to root of 1 minus cos x upon 2. This is equals to root of 1 minus root 15 upon 4 upon 2, which is equals to root of 4 plus root 15 divided by so this is 4. 4 will come in the denominator, which is 4 into 2, 8, root 8. This is equals to root of 4 plus root 15 on 2 root 2, and root 2 can be rationalized by multiplying and dividing by root 2 to give you root of, if you introduce 2, you get 8 plus 2 root 15 upon 4. Next, your cos x by 2 will be equal to root of 1 plus cos x upon 2. This is equals to root of 1 plus cos x is calculated as minus root 15 upon 4. Minus root 15 upon 4. 1 second. Yeah. Whole upon 2. So this is equals to root of, again 4 will come over here, 4 minus root 15 upon 8, because 4 will come in the denominator. This is equals to root of 4 minus root 15 upon 2 root 2 into root 2 upon root 2. This is equals to root of 8 minus 2 root 15 whole upon 4. Cos x by 2. Tan x by 2 is equals to sin x by 2 upon cos x by 2. This is equals to root of 8 plus 2 root 15 whole upon 4 upon root of 8 minus 2 root 15 whole upon 4. This will be equal to root of 8 plus 2 root 15 upon 4 multiplied by 4 upon root of 8 minus 2 root 15. 4 will get cancelled, and you have tan x by 2 is equals to root of 8 plus 2 root 15 upon root of 8 minus 2 root 15. So this concludes this exercise. Thank you.